Hello. This video is explaining how our context-aware access control infrastructure works. Let's see what it looks like. This infrastructure is aimed to gather contextual information to deduce a risk level associated with a user. For instance, contextual information may come from connected devices, or from audit events, stored by Web Access Manager. Let's imagine that we have security cameras at some elderly people's homes. How can we allow these privacy rules to be overridden when, for example, the person is in danger? That's why we have to take in consideration contextual information. In this example, an alarm button can be triggered in case of danger. For example, an elderly in need of help. Let's put it into practice. We first have to know that the camera and the button are linked to the same user. This is done through an enrollment procedure managed by Web Access Manager. Here is a demo to understand how it works. We start by creating an alarm button that we call Werner, which corresponds to the username of the elderly person to whom this button will belong. First, the alarm button needs to enroll itself to be linked to its owner, and to get an access token that will allow it to access API. We activate the refresh token function to allow the device to obtain a new token when the previous one has expired, without the need for the user to grant permission again. We'll set it to the automatic mode and start the enrollment. A code is displayed to the user, and the URI the user should visit to enter the code and give his consent for the device to access his information. The user copies the code and goes to the provided URI. First, the user must authenticate himself. Then he can enter the provided code. Here's what the device is requesting access to. In addition to the standard user information, a custom scope named security is requested which contains the risk level associated with the user. This risk level is computed on the basis of contextual information. We will be explaining this later on. Now let's go back to the Werner's alarm button. You can now see the access token details. You can also find them in the button details. So now we can see what influence the action on the button has on the risk level associated with the user. The principle is that if the alarm button is activated, the risk level is lowered to grant more access to the devices belonging to the user in danger. And vice versa, when we press again the button to disable the alarm, the risk value goes up. What we need to understand is that, the more critical the contextual information, the lower the risk, and the greater the access to resources. But how is the risk value calculated? When we push the button, it sends a status plus the device owner's user ID to the input processing interface. It then publishes both of them to a topic Kafka. After that, the risk server receives the event from the NIFI interface. The ingest data interface stores in its cache the risk values sent by the risk server. These values are stored according to their associated user's identifier. Now let's take interest in the device, the camera in our example. We first need to enroll the device to get an access token. The user copies the code. Then he authenticates himself, enters the provided code, and authorizes the device to have access to requested resources. When the device wants to access a resource on a back-end server, it requests the server by sending it its access token. The server can then request Web Access Manager to check the token, and get the corresponding user information, including the user's risk level. Now let's go to the back-end server side. Here is the user information obtained from Web Access Manager by checking the provided access token. As you can see, there is a scope named security. It contains the contextual risk level for the user associated with the device. When the backend server calls the user info API of the access control tool, the post-authorization plugin of this tool retrieves the user's risk level from the cache, and injects it in the user info, so that the backend server can take this into account in its access management. Let's firstly add some buttons with usernames and user IDs. Let's head to Generate Button Data and select the parameters that suit you. Now let's set allowed buttons to all buttons with a user ID, the data sending mode to random, and the number of requests per button to 10. This API can be used for different tests. to test how much data this infrastructure can handle simultaneously or to observe the trust levels evolution of users. You can check the logs by activating them and look for potential anomalies. In the Edit Buttons tab, you can change the Refresh Token API mode, remove tokens, or delete buttons. Thank you for listening. I hope this was clear.